Imagine this. A quiet table. No sound, no movement. On one side, a small magnet. On the other, a paperclip. Nothing touches. No wires, no force applied. And yet, slowly, almost shyly, the paperclip begins to move. Sliding. Pulled. As if something invisible is calling it. We've seen this since childhood, so we don't react. Magnet high, we say, then move on. But stop for 1 second. Ask yourself honestly, why did it move? No contact. No push. No visible connection. Just empty space in between. Now here's where it gets uncomfortable. One day, someone asked this exact question to Richard Feynman, a man who understood physics deeper than almost anyone in history. Why do magnets attract? And Feynman paused and said something shocking. He said he couldn't really explain it. Not because he didn't know the equations, not because science had failed, but because the why of magnetism goes so deep that at some point explanations stop feeling solid, and suddenly that quiet table doesn't feel so normal anymore. Because if a paperclip can move without touch, what else is happening around us that we've stopped questioning? Think about the first time you ever saw a magnet. You probably don't remember it. Not because it wasn't impressive, but because it happened too early. फ्रिज डोर पे चाबी चिपकी हुई, स्कूल बैग के कंपास का नीडल घूम रहा है, टॉय ट्रेन ट्रैक जो अपने आप जुट जाता है. We grew up with all this, so our brain quietly decided, normal hai. But imagine seeing this for the first time today as an adult. You put your keys near the fridge. They jump and stick. No glue, no hook, no effort. It's almost like the fridge whispered an order, and the keys obeyed. If this happened in a movie, we'd call it magic. But because it happens in the kitchen, we call it boring. That's the strange trick of the human mind. Familiarity kills wonder. We stop asking questions not because we got answers, but because we got used to the mystery. Here's the uncomfortable part. If someone today claimed, I can pull metal using invisible forces through empty air, we'd raise an eyebrow. We'd ask for proof. And yet every single day magnets do exactly that. And we don't even clap. No smoke. No sound. No drama. Just quiet obedience. The truth is, magnetism feels obvious, only because we learned its result before we ever questioned its cause. We were shown what happens, but we never pause to ask why this should happen at all. And once a mystery becomes routine, our curiosity goes to sleep. That's dangerous, because nature doesn't stop being strange just because we stop being curious. Magnetism isn't simple. It's not just attraction. It's a force that works without touch, through empty space, following rules we didn't invent, and the moment you really see it, not as a toy, not as a school fact, but as a behavior of reality itself, you start to feel that mild shock. Wait, this is weird. And once that feeling wakes up, we're ready to ask the next question. How can something act without ever touching it all? Let's slow down and focus on the strangest part, the space between the magnet and the paperclip. Nothing is there. No wire, no hand, no contact. And still something happens. For most of human history, this idea felt impossible. If you wanted to move something, you had to touch it, push it, pull it, kick it. Action meant contact. So when people first saw magnetism, it deeply confused them. How can one object affect another? From a distance. Imagine two people standing a few steps apart. No rope, no connection. And yet they feel a pull, like an invisible tension between them. That's exactly how magnetism behaves. Not like a shove, not like a grab, more like a silent influence. This idea was so disturbing that early scientists tried to avoid it. They didn't like action at a distance. It felt like cheating. Newton himself was uncomfortable with gravity for the same reason. How can the Earth pull the moon? He wondered. Without touching it? Magnetism raised the same unsettling question. If objects don't need contact, then what really connects them? For a long time, people imagined hidden strings, invisible fluids, secret particles flying back and forth, anything to save the idea that touch was required. But magnetism refused to cooperate. No matter how carefully you looked, there was nothing in between, just space. And that's when a terrifying possibility appeared. What if space itself is doing something? What if nothing isn't really nothing? That single thought quietly changed physics forever. Because once you accept that influence can travel without touch, the universe becomes a very different place. Light can travel. Gravity can pull. Signals can cross emptiness. Reality no longer needs fingers to interact. Magnetism was one of the first hints that the universe doesn't work the way our hands do. It works through something deeper, something invisible, something spread out. And to understand that, we need to stop staring at the magnet and start looking at the space around it. At this point, it's tempting to think the magnet is doing all the work, as if the force lives inside it and somehow reaches out to grab things. But here's the quiet twist. If you remove the paperclip, the magnet doesn't stop doing anything. Something is still there. Imagine a fish in the ocean. It swims, turns, speeds up, slows down, but it never feels the water as an object. For the fish, water is just normal. Now imagine the fish suddenly realizing, oh, this invisible stuff around me is shaping every movement. That's exactly what physicists realized about magnets. The pulling doesn't come from the magnet jumping across space. It comes from an invisible structure around it. We call this a field. Not a thing you can hold. Not a substance you can scoop. More like a condition of space itself. If you sprinkle iron filings around a magnet, something magical happens. They don't pile up randomly. They draw patterns, curving lines, smooth shapes, as if the empty air suddenly revealed a hidden map. Those patterns aren't created by the filings. They were already there. The filings just made the invisible visible, and that's the realization that changes everything. The magnet isn't pulling the paperclip directly. The space around the magnet is different, and the paperclip simply responds to the space it's sitting in. This idea feels subtle, but it's revolutionary, because it means space is not passive. It's not just a stage where events happen. Space participates, it carries instructions, it carries influence, even when nothing seems to be there. Once you accept that, magnetism stops being a weird exception and starts looking like a rule. Because light moves through space, gravity bends space, and magnetism shapes space, the universe doesn't whisper commands through touch. It reshapes the space around things and lets everything else respond. And now that we know where magnetism lives, the next question becomes even stranger. Why does only some matter listen to this invisible space, while other matter completely ignores it? So far, it feels like magnetism is everywhere in space. But then another puzzle appears. If the space around a magnet is special, why doesn't everything get pulled in? Why doesn't your wooden table rush toward the fridge? Why don't plastic bottles fly across the room? Same space, same field, different behavior. To understand this, we have to go inside the magnet. Not with a knife, but with imagination. Picture a massive stadium. Tens of thousands of people. If everyone moves randomly, nothing special happens. Just noise. But the moment people start coordinating, standing up and sitting down together, a wave is born. No single person creates it. The power comes from alignment. Inside a magnet, something very similar is happening. Every atom is like a tiny compass. Each one has its own microscopic magnetic direction. In most materials, these tiny compasses point everywhere. Left, right, random. They cancel each other out. So from the outside, nothing. But in a magnet, millions and millions of these tiny compasses are aligned. Not perfectly on, but enough. And when they align, their effects add up. Suddenly, the space around the object changes. Suddenly, a magnetic field appears. This is why magnetism feels so selective. It's not that magnets are magical. It's that order has emerged at a microscopic level, and only certain materials allow this kind of order. Iron, nickel, cobalt. They have atoms that can agree with each other. Most materials can't hold that agreement for long. That's why you can magnetize a nail and watch it slowly forget. The alignment breaks. The wave collapses. This is one of the most beautiful ideas in physics. A force that looks powerful and mysterious from far away is actually born from tiny decisions happening at an invisible scale. No leader, no command center, just alignment. And once you see that, magnetism stops being a trick and starts looking like a message. That nature doesn't always rely on strength. Sometimes it relies on cooperation. And this hidden cooperation leads us to an even bigger surprise. Because magnetism doesn't exist alone. It has a secret twin hiding in plain sight. Up to now, magnetism already feels deep. But then physics does something unexpected. It connects it to something that feels completely different. Electricity. For a long time, people treated them as separate worlds. Electricity was sparks, shocks, lightning. Magnetism was fridge magnets and compasses. Different lessons. Different boxes. Until someone noticed a strange coincidence. Whenever electricity moves, magnetism appears. A wire with no current, nothing special. But the moment electrons start flowing, suddenly the space around the wire changes. A compass nearby turns, as if motion itself created magnetism. This discovery shocked scientists, because it meant magnetism wasn't a permanent property. It could be created, just by motion. Here's a way to feel this. Imagine holding a coin. When it's still, it's clearly a circle. Now spin it fast. So fast that it blurs. Suddenly it doesn't look like a flat disk anymore. It looks thicker. Different. Same object, different behavior. Electricity and magnetism are like that. When electric charges are still, we call it electricity. When those charges move, we see magnetism. Not two forces, one deeper phenomenon, viewed from different situations. This is why a moving magnet can create electricity, and moving electricity can create magnetism. They transform into each other. And this unity isn't just elegant, and it's practical. Every motor you've ever used works because of this dance. Every generator, every power plant. Motion creating fields, fields creating motion. Nature isn't interested in our labels. It doesn't care what we call electricity or magnetism. It prefers simplicity underneath complexity. And once you see this hidden connection, a deeper question starts to form. If magnetism can be explained through motion and fields, why did Feynman still say he couldn't explain why it exists at all? After everything we've uncovered, it feels like we're close. Fields, tiny compasses, moving charges. So when someone asks, why do magnets attract? It feels like we should finally have a clean answer. And yet, this is where Richard Feynman stopped. When a student asked him that question, Feynman didn't launch into equations. He did something more uncomfortable. He said, in essence, I can describe how magnetism behaves, but not why it exists in the first place. That sounds strange coming from a genius, but his point was subtle. Imagine trying to explain color to someone who has never seen light. You can talk about wavelengths, about frequencies, but at some level you hit a wall because your explanation rests on shared experience. Physics works the same way. When we explain magnetism, we say, charges create fields. Fields influence matter. But then the honest question appears. Why do charges create fields? Why do fields influence matter? And the answer is, because that's how the universe is built. Not because we're lazy. Not because science failed. But because every explanation eventually rests on something we accept as fundamental. Feynman wasn't refusing to explain magnetism. He was refusing to pretend there was a deeper why hiding just one layer below. At some point, explanations stop being answers and start being descriptions. This realization is humbling. It reminds us that physics doesn't tell us what reality means. It tells us how reality behaves. And magnetism is one of those behaviors we can map beautifully, without ever touching its ultimate reason. Instead of being disappointing, this is powerful, because it shows honesty at the heart of science. We don't invent reasons, we discover patterns. And magnetism, quietly, is one of the clearest patterns we've ever found. Which brings us to the final thought. If magnetism isn't just a force, if it's a pattern written into space itself, then maybe it's not asking to be explained. Maybe it's asking to be understood. Let's take a step back now. Forget magnets on fridges. Forget paper clips and compasses. Look at what magnetism has been quietly teaching us all along. It shows us that reality doesn't run on solid objects alone. It runs on relationships, invisible ones. Just like ripples on water reveal wind you can't see, magnetism reveals a structure in space that would otherwise stay hidden. Nothing visible moves first. No object reaches out. And yet behavior changes. That's the clue. Reality isn't just made of things. It's made of fields. Patterns spread across space telling matter how to move. This idea didn't stop with magnetism. Gravity turned out to be a shaping of space. Light turned out to be vibrations of fields. Even particles, the solid dots of the universe, are really tiny excitations in invisible structures. Magnetism was one of the first hints that the universe is not built like a machine, but like a fabric. Stretch it and something far away responds. Disturb it and the effect travels. This isn't philosophy. We use this every day. Your phone works because electromagnetic fields carry information. Satellites talk to Earth through empty space. MRI machines read your body using magnetic patterns. All of it depends on space being active, not empty. And once you truly see this, a quiet realization settles in. We don't live in a universe of isolated objects. We live in a universe of connections. Invisible, continuous, and deeply ordered. Magnets don't just stick things together. They whisper something profound about reality. That what matters most is often what we cannot see, and maybe that's the deepest lesson of all. If space itself can carry influence, if invisible structures shape everything we touch, then what other patterns are surrounding us right now, waiting for us to finally notice them? So let's gather everything we've seen, not as separate facts, but as one story. We began with something ordinary, a magnet, a paperclip, a silent pull. Then we noticed what we usually ignore, that this pull happens without touch. That led us to a deeper idea. The space around objects is not empty. It has structure, it has rules. We went inside matter and saw that powerful forces don't always come from strength, but from tiny alignments, millions of small things agreeing at once. Then the surprise. Magnetism and electricity are not enemies or cousins, but the same thing seen from different angles. And finally, we reached Feynman's honesty. That science doesn't always give us a final why, only clearer and clearer descriptions of how reality behaves. Put together, magnetism stops being a trick of metal. It becomes a message that reality is not built only from solid objects, but from invisible patterns spread across space. That space itself is active. That influence doesn't need touch. That connection is more fundamental than contact. Magnetism isn't just a force you learned in school. It's one of the first cracks in the idea that the universe is simple, solid, and obvious. It hints that what we call empty is actually full. And once you accept that, you start looking at the world differently. So here's the question I'll leave you with. Not to answer quickly, but to sit with. If invisible fields shape magnets, electricity, light, and gravity, how much of reality is guiding us right now, without us ever noticing it?